Pluto, once regarded as the most distant and elusive planet in our solar system, has experienced a fascinating journey through both scientific discovery and public perception. Originally considered the ninth planet, it was reclassified as a dwarf planet in 2006. Yet, despite its demotion, Pluto has continued to captivate the minds of astronomers and the public alike. Recently, its name has once again been thrust into the spotlight, thanks to the startling remarks of renowned astrophysicists like Neil deGrasse Tyson and Michio Kaku. These two celebrated figures in the world of cosmology have raised alarms about Pluto's potential collision course with Neptune, an event that could have extraordinary implications for our understanding of the cosmos. But is such a dramatic event truly on the horizon, or is it merely a wild hypothesis built upon misunderstood possibilities? How could two celestial giants like Pluto and Neptune potentially collide, and what would the aftermath of such a cosmic catastrophe entail? Are we witnessing an anomaly that defies reason, or is there a deeper, more mysterious force at play in this slow-motion celestial dance? Let's delve into this fascinating theory and explore the tantalizing possibility of a Pluto-Neptune impact. Despite its reclassification, Pluto continues to intrigue scientists and space enthusiasts. It remains a subject of study and fascination in the broader field of astronomy, particularly due to its unique and eccentric orbit. As many of us know, Pluto's journey around the Sun is far from ordinary. Unlike the other planets that follow relatively predictable paths, Pluto's orbit is remarkably elliptical, which means it swings in and out of our solar system's plane. This path, combined with a tilt of about 17 degrees relative to the ecliptic plane, gives Pluto's orbit a distinct irregularity. Such a peculiar orbit immediately raises important questions. Why has Pluto not collided with Neptune, despite their paths crossing at certain points in their orbits? The answer lies in the intricate and fascinating physics that govern the orbits of celestial bodies, specifically the three-body problem. The three-body problem is one of the most perplexing challenges in astrophysics. It involves determining the gravitational interactions between three celestial bodies and predicting their movements over time. Think of it as trying to forecast the path of a ball in motion, but with each object pulling on each other with its own gravitational force. When it comes to Pluto, Neptune, and the Sun, their gravitational pull on each other creates a delicate balance that, though precarious, keeps the two planets from colliding. At the core of this cosmic harmony is the concept of non-concurrent libration. This phenomenon ensures that when Pluto's orbit intersects with Neptune's, the two planets are always positioned at least 90 degrees apart, thus preventing a direct collision. In essence, this spatial division ensures that while Pluto and Neptune may cross paths, they are never in the same place at the same time. This celestial safeguard prevents the planets from colliding despite their overlapping orbits. But that's not all. There's another crucial force at play that adds an additional layer of protection to Pluto's orbit: orbital precession. This refers to the slow, vertical movement of a celestial body as it travels along its orbit. For Pluto, this means that when it gets closest to Neptune, or any other giant planet in our solar system, it is positioned far above the orbital plane of those planets, reducing the chance of any catastrophic collisions. But perhaps the most fascinating of all these forces is the VSK wobbling, named after researchers Zell, Kai, and Kaku, who studied the gravitational interactions between Pluto, Neptune, and the Sun. This wobbling effect ensures that despite the apparent chaos of Pluto's orbit, it remains remarkably stable over long periods of time. Numerical simulations from the late 1980s have further illuminated Pluto's remarkable stability. While Pluto's orbit can appear erratic over short periods, these simulations revealed that its path remains steady over vast timescales, millions, even billions of years. This stability is largely attributed to the gravitational influence of the giant planets like Neptune, Jupiter, and Saturn. These massive giants are not just passive participants in the solar system, they actively shape the orbits of smaller bodies like Pluto, helping to stabilize them and prevent dramatic disruptions. Interestingly, Neptune plays a key role in Pluto's stability. For every 2 orbits that Pluto completes around the Sun, Neptune completes 3. This gravitational resonance keeps Pluto's orbit locked in place, preventing it from veering too far off course. Yet it's not just Neptune's gravity that protects Pluto. Jupiter, with its immense mass, also contributes to the stability of Pluto's orbit. Saturn, too, lends its influence, ensuring that Pluto remains on a steady path. Together, these massive planets form a gravitational network that shields Pluto from danger, keeping it on a relatively safe trajectory in the solar system. But what would happen if these gravitational forces were to shift even slightly over long periods? The possibility of Pluto's orbit becoming unstable over billions of years is something that cannot be ruled out. The delicate gravitational balance between Pluto, Neptune, and the other gas giants could shift, causing Pluto's orbit to become unpredictable. Should this happen, Pluto might stray into a collision course with Neptune, or even be ejected from the solar system entirely. This potential for cosmic chaos is a reminder of how fragile our understanding of the universe truly is. Even seemingly stable systems, like the orbits of planets, can be vulnerable to subtle changes that accumulate over vast stretches of time. The idea of Pluto colliding with Neptune, while unlikely in the near future, highlights the delicate nature of our solar system, and the potential for dramatic shifts in its dynamics. What seems stable now might one day become unstable, opening up the possibility for unforeseen events. The intriguing possibility of a Pluto-Neptune collision has raised concerns among leading astrophysicists, including Neil deGrasse Tyson. Tyson, a prominent voice in modern cosmology, has long been a proponent of continually updating our understanding of the solar system. He famously led the campaign to reclassify Pluto as a dwarf planet, emphasizing that our knowledge of the cosmos is always evolving. Tyson believes that Pluto's reclassification was an important step in refining our understanding of planetary bodies, and he sees the complexities of orbits like Pluto's as a sign that there is much more to learn about the solar system. Yet Tyson's perspective on the potential collision between Pluto and Neptune is less optimistic. While the gravitational dynamics that currently govern the orbits of Pluto and Neptune are stable, Tyson and others caution that subtle changes in these forces over billions of years could eventually destabilize their paths. If such a shift were to occur, even the slightest gravitational perturbations could push Pluto into a collision course with Neptune. Although the probability of this happening anytime soon is incredibly low, the possibility of a dramatic cosmic event remains a concern for the distant future. Tyson's warning serves as a reminder of the unpredictable nature of space. While we have made great strides in understanding the forces that govern our solar system, the vast timescales and complex interactions at play make precise predictions difficult. Even the smallest changes in the gravitational relationships between planets could result in dramatic consequences. The case of Pluto and Neptune is a perfect example of how space, though seemingly stable, is in a constant state of flux. As we continue to study these celestial bodies and their orbits, we are reminded of the importance of constantly refining our models and simulations. The study of planetary orbits and gravitational interactions is a dynamic field that evolves alongside advancements in technology and observation techniques. Future discoveries and simulations could provide new insights into the long-term stability of the solar system, helping to refine our understanding of the cosmic forces that shape it. In conclusion, while the prospect of Pluto colliding with Neptune remains an unlikely and distant possibility, it offers a captivating glimpse into the ever-changing nature of our solar system. Pluto's orbit is an enigma, a chaotic yet stable dance that continues to puzzle and fascinate scientists. Understanding its path and the forces that govern it is crucial to unlocking the mysteries of not just Pluto, but the solar system as a whole. The study of Pluto and its potential for future interactions with Neptune reminds us that space is not a static place, but one of constant motion, change,